You are now watching the demonstration video of Vasavi Solar Grid Tie Micro Inverter. This grid tie micro inverter can generate up to 600 watt solar power, and this inverter is as good as having two 300 watt micro inverters under single enclosure. As you can see, this inverter has got two separate set of PV connections, one to the left side and the other to the right side of the inverter, and each side can be connected to 300 watt solar panels, and you don't need any extra wiring or you don't need any extra connectors to connect this to the PV. And this also has got two sets of connectors, and those connectors are to connect to the next inverter, and the end of the branch can be connected to the grid. Here is a specification sheet of grid tie micro inverter. At the top you can see this is a recommended solar panel specifications. That means the input DC for the inverter. So the recommended solar panel can range from 230 to 300 watt, and the open circuit voltage should not cross 60 volts, and the peak power voltage can be something around 27 to 45, something between that. It means a nominal 36 volts should be a better optimal solution, and maximum DC short circuit current should not cross 15 amperes. Maximum power current should not cross 9.7 amperes. And down here is the output data. This can generate a nominal output voltage of 230 volts. So it synchronizes with the grid power, and that can range from 195.5 to 253 volts of AC. And the nominal operating frequency, it means it can synchronize from 49 to 51 hertz frequency. And you can see it has got the other specs. Anyway, we can share you the specification sheet once we get an inquiry from you. I am now showing you the working of grid tie micro inverter. We are just connecting one side of the PV to a DC power supply that works as a PV simulator that can provide you the requisite voltage and the requisite current. So we are just leaving the other PV empty. So now it means this solar can generate up to 300 watt as of now. So to the one side of the grid connection, the one side of the AC connector, we have connected to the panel meter, and the panel meter shows the required AC parameters. And here we have given a provision of applying some load to the output. We are loading by putting some electric bulbs. Reason of taking an electric bulb is it has got a better power factor. I now have switched on the DC power supply, and I have given a grid connection to one side of the AC connector, and as you can see, that is connected to the panel meter. And though the input voltage is on, the inverter will not generate any solar power unless or until it has the input PV voltage. But nevertheless, it doesn't mean that all your appliances will shut down. As long as the grid connection is there, it doesn't interrupt any of your appliances. So here I'm increasing the PV voltage so that it reaches 36 volts, and I have I have adjusted the current so that I just get 8 amperes for the protection, but the spec shows we can go up to 9.7 amperes. So you can see in the panel meter it can show various parameters of AC, the AC voltage, that's the line to neutral AC voltage, and the current, AC current, and the last is the frequency. You can see that's 50 hertz. As I press this button, it now shows the ampere, the power factor, it's the power and the power factor. So here you can see if there is any current driving, it means that the inverter is now on. We are now testing the inverter by applying some load to the output of the inverter. We have applied the load by switching on the electrical bulb. The electrical bulb is rated with 200 watt, but it is taking only 180 watt. You can see in the power supply it it shows you the output voltage, and it also shows you the current, so that you can just note down those for calculating the efficiency. You can see it is showing 35.9 and 7.9 current. So we now see the output characteristics. We now read the VAC. 230 volts is the output voltage and 1.18 is the current. I just press the button to read the power. 269.1 is the output power. So I've just noted down those readings. The input VDC is 35.9 and the input current is 7.9, and the output VAC is 229.7 and IAC is 1.190, and the output power is anywhere read as 269.2. So now I just calculate what was the input power. So as we know, the efficiency is calculated by power output by the power input. So here when we divide the output power with the input power, we are getting we are getting 94.9. It's nearly 95%. So the 95% conversion efficiency is really fantastic. So this is how I prove my inverter to be the best.